Welcome back to the stream. Looks like we are getting the bits flowing. This is going to be a pretty chill programming kind of stream. I'm kind of getting in over my head with Rust, trying to implement a kind of a custom async executor in a weird environment. So that might be interesting. Maybe the cat will visit. Hi. Gonna enjoy the fake weather on the green screen. Got this camera ready for Tuco if he comes back. Oh, Tuco, are you gonna join? Looks like we are live on YouTube on the Scanlime-in-Progress channel, as well as on twitch.tv/scanlime. And probably on Diode Zone too. Let's check that out. Oh yeah, don't get autoplay, but here we go. So, oh, is Tuco back? Perfect. Welcome back to the stream, everyone. Let's move this camera up a little bit. Clearly I need a robot for that. Good relaxing start to the coding session. Oh, he's so purring. I don't know if I can get a microphone over there without disturbing this delicate situation. He's just like leaning into my hand. I guess I could fill you all in on why this project is kind of weird while I'm petting the cat. It's like half that it's a weird project and half that I'm just new at Rust, so I'm kind of getting my feet wet in a lot of fairly strange areas that I wouldn't otherwise necessarily get into if it wasn't for the strange low-level project. This cat. think I can move this without disturbing him too much. Let me try to catch up on chat, sorry. I need to get a slightly better way of mounting this screen that I've got the chat on, because it's just tiny right now. Oh, that's a good question. How old is Tuco? Gosh, I was just figuring it out recently. He's a little over 7 years old. He's a really great cat. Yeah, he has some nice chill moods when he's not in the mood to tear stuff up. He and I have been pretty in sync lately. It's been nice. I've found a food routine that so he's super picky about food, but I've got figured out sort of how and when to feed him where he doesn't seem to mind, and he seems pretty excited about his food. That's another good question. Do I miss my old place? Yeah, I mean, I definitely miss my neighbors. I've been wanting to go visit them. I've just been kind of avoiding taking the travel because of COVID. If there wasn't a pandemic on, I would be trying to visit my former neighbors fairly frequently, and especially now that I've got a housemate here where, like my housemate could watch Tuco for, a day or two, like I could probably go visit my former neighbors and hang out. And I can do that now. It just involves taking a long train trip, which is something that, I could do, but I don't want to do like unnecessarily, I don't want to risk people's health unless there's a pretty good reason. And so, I don't know, I guess I haven't let the trip to visit neighbors or former neighbors rise to that occasion, but maybe I should. Yeah, I miss the train too. It was nice just taking the train a lot, and I was also just really starting to enjoy wandering around the city, because I just moved, I moved here right before COVID, and so, I'm lucky that I didn't move, right after COVID, because that's a lot harder, but, oh, oh yeah, the LED light on the back is kind of nice. I've been meaning to mount it on the ceiling, because it's slightly in the way on the floor. Harry is asking how I've been. I've been alright. Thanks for asking. Been mostly just trying to figure out what to do, and been, I don't know, finding it kind of nice to be digging into a tech project that seems kind of useful, but it's also all within the context of computers being kind of a hugely problematic thing. So it's kind of hard to just feel good about it, but it's, an improvement. I'm going to try to stream more regularly. I was thinking the last couple of days, I probably could stream without it being a huge hassle or anything. I just felt like I didn't have anything really solid that I wanted to show off or whatever. I felt like I was still figuring my way around stuff that I don't really understand. And so I don't know, it's I made a little bit of progress on that, but I also felt maybe just more comfortable with sharing the process. Tuco is such a puddle right now, gosh. Let's see if I can zoom in on him. Oh, what a cat. He is the sweetest baby. The old place was pretty weird, yes. It was definitely industrial. It was like, it used to be a factory, and then it got, over the course of decades, turned into various different configurations of like artist studios and live work lofts and small businesses, and eventually just kind of like more regular like apartment lofts. And it was always a weird building full of like a whole mix of stuff, but it was always also like way too expensive. So like it was nice to get out of there and to stop having to pay the ridiculous rents. But it was nice for what it was, for sure. And I do miss the people from there. I'm like picking at Tuco's like eye fuzz. I think sometimes he appreciates it when I get something crusty out of his eye, but it's like such a mom thing. Yeah, the rent at the old place was ridiculously high because it was just, I mean, it was like Bay Area rents. It was Bay Area market value, which is ridiculous, and it was a lot of space. So, I mean, I was hoping when I got it that I would be able to use it as some sort of like a venue for activities that had to be local to the Bay Area, but I only did a little bit of that. Like, I mostly didn't have the mental health and the interest to make that work long term. So, like, it eventually just turned into a really expensive place for me to have like my like shop tools and computers and cat. Oh, this cat is so good. Yeah, it makes me so happy when Tuco and I get along well. Oh, I wish I could change the layout of some of these dashboards so that I could see the YouTube and the Twitch chat both better at the same time. Hello, hello. Drago on Twitch says, "Oh, a cat stream." Yeah, we're lucking out, really. I mean, my plan for this stream was to make it a Rust stream, and I still got that on the computer queued up here. But Tuco's in such a great spot, and the camera hasn't overheated yet. So as soon as Tuco leaves or the camera overheats, then we can get back to the programming. I wonder if I can carefully move this to get a better view of his face. Yeah, I want to put that light bar on the ceiling and or build something a little more special purpose. The goal is just to get even lighting on the green screen. And I mean, green light is more useful than white light because that also just serves to punch up the greenness of the green screen. But like the evenness is mostly what's important. And so putting a bar on the floor or on the ceiling is all right, but there's probably other light configurations that would work a little better. That's a good question. It's a question about whether I'm planning a project that includes embedded Linux, that maybe a Yocto Linux live stream could be fun. Yeah, that could be interesting. Yeah, the stuff I've been working on just recently is more in the vein of trying to support like decentralized video sites. So, just like adjacent to what I've been trying to do with Diode Zone, the ongoing video site that I've been doing, the PeerTube instance. And while I like PeerTube and I like running it, I also am always frustrated at the storage backend, and just generally think it would be interesting to try having an architecturally different but still compatible open source video server. So I got some more motivation to do something like that. yeah, I found a collaborator who's more interested in the kind of front end side of it, and I'm kind of more interested in the back end side of it, and we're actually maybe gonna do a thing, but still trying to feel out what the technology pieces are like. And so I've been building some stuff. I've put a bunch of experimental Rust up on Git recently. Put my repos up on GitHub so that people could poke at them if they care. Mostly because I was going to be looking at them on stream and figured it would be useful to have them on there for reference. So I've got this video server I've been experimenting with that takes input from just some FFmpeg compatible place, and it really relies on FFmpeg as much as possible. But then the thing I'm really trying to experiment with is whether I can use storage that is compatible with IPFS, and how much I can make the video segments and the IPFS blocks just like one-to-one mapped to each other. So I've got this like proof of concept I've been hacking on in Rust, which has been kind of fun. And one of the components of that is like a container-based transcoder where I'm using these FFmpeg binaries that are intended to be sandboxed and versioned so that you can have reproducible media transcodes, and you have some extra isolation against people with 0 days in codecs. So the proof of concept video server thing is using Podman for that, but I want to try to experiment with something that's more like library level, something that like any old Rust program can just link with and get like a library level sandbox, just like a thing that you can instantiate like a process like you would with a standard process command. And, you know, it wouldn't have system level requirements, like you wouldn't have packages you'd have to install, it would just be like a Rust binary. So I've been experimenting with building something like that using, let's see, I mean, the architecture is like roughly similar to gvisor, but I've been building it with fairly low-level pieces. Like the parts inside the sandbox so far are mostly like no standard, like Rust code without the standard library, and raw system calls. And then the stuff outside is higher level, like async Rust code using Tokio, which is a powerful and popular asynchronous I/O framework for Rust. Dooku's so good. Computer fell asleep trying to do the cat petting. That green fuzz on his ear. I know. That's a good question. There's a question. I can't quite read the username from here. Somebody from YouTube is wondering how many years I've spent with programming. Like 30. I've been doing it too long. I mean, it's been with a lot of different kinds of computers and languages and places and whatever. But yeah, I mean, I started out when I was really young with BASIC on an IBM PC. So it was something my dad had at home so that he could take work home for his job building space junk. And he had a basic interpreter that he used for doing like Monte Carlo simulations of orbits and that kind of stuff. And didn't ask too much about what his work was really about, but I learned how to use the basic interpreter mostly by reading the manual. I can remember him teaching me the basics and then just like handing me the book. So I did basic for a while, but then yeah, a few years later I got interested in C and C++ and I started learning them. For a long time, like C and C++ were basically like my go-to language for things. I liked Python. Well, I still like Python a lot. For a while I was into Perl, like back when that was, I don't know, back when it was like a very kind of uniquely handy sysadmin kind of tool in Linux especially, and when it was useful for like early web programming. I've got a fondness for various kinds of assemblies. I don't know if I'd say my dad was cool, but I mean, it's definitely a thing that happened that he got me started programming. Well, I guess Tuco's leaving us for the moment. Yeah, I mean, I used to think it was cool to have family that was like into rocket science or whatever, but now I realize that like it's mostly just an excuse to make weapons, so I'm not so into it. I agree, the cat is very good. Sorry, YouTube is automatically profanity filtering here. Oh my gosh, I didn't realize there was a Rust emoji for Twitch. That's amazing. Today I learned something not depressing. Alright, so yeah, this is supposed to be a weird library sandbox kind of thing. I keep finding that the consoles I run this on squish the emoji together because nobody really agrees on how wide emojis are supposed to be in consoles, so I should probably put a space there. Tuco's talking again. So yeah, this is just the kind of really simple high-level driver program to create one of these container objects and put it through some paces. I think this is currently in a super broken state. This was like the last binary that actually compiled, but I've been kind of ripping out pieces and it's probably not actually compilable right now. Yeah, I think my feelings about what a task and a process like specifically are have been refined since I wrote some of this code. I started writing a bunch of the just like skeleton of this, what's basically like a ptrace syscall emulator, assuming that there was going to be some kind of process ID virtualization. There's some like internal notion of a process that corresponds one-to-one to a process inside the sandbox, has maybe some other correspondence to processes outside the sandbox, and that there are maybe ways of determining for a particular inner process ID what the outer process ID and vice versa is, and determining for a particular outer process ID whether it belongs to the sandbox or not. All of these things are somewhat fraught, which we could get deeper into right now, but it's probably best to leave that rabbit hole for later. This particular journey was more about how these process IDs interact with the internal like state machine behind handling system calls, and this all kind of comes down to figuring out how the I/O strategy works for this process. So I've got one of the processes in the sandbox is involved in mostly just acting as a ptrace-based system call emulator. So it's sort of like a debugger that attaches to whatever other processes are running in the sandbox and intercepts some portion of its system calls using a setcomp filter. So all of that is kind of set up, and I'm in this position where, actually it just happens to be right here in the diff, I've got this waitID system call, which blocks this process. And so again, I've got like n processes inside the sandbox that need monitoring, but they can all be monitored by one of these single ptracer processes. Could have more for performance, like to use multiple cores, but like I don't expect this to be a performance bottleneck, so it simplifies this a lot to have just a single tracer process, I think. This ptrace interacts like not at all usefully with threads, so it would probably be more pain than it's worth to try to use threads in this part of the program. So this is mostly good where I can just wait until some event comes in, which is like a system call being initiated on any process, and it tells me which process. The kernel fills in this info structure with information about what event just happened. But the wrinkle I'm hitting is when I also want to handle system calls that require communicating back and forth to this higher privileged process that I have on the other end of an inter-process communication mechanism. In this case, it's a Unix domain socket that is shared with the inside of the sandbox as the runtime outside the sandbox creates the whole process. And I need to wait on the results of those messages to come back. You know, I need to be able to, if not do both asynchronous writes and asynchronous reads, at least get like an asynchronous notification when a message is ready. But then I started thinking about like what framework that actually fits into. You know, the way this is actually going to work is probably a system call comes in for emulation, then it gets converted into some other thing, which is probably one or more inter-process communication calls and some other emulation on top of that. So this maps really well with Rust's asynchronous support, not necessarily with any existing I/O libraries or executor, but the actual language support for asynchronous is actually probably really close to what we want here. So I've been trying to understand how to do like low-level async stuff in Rust, like how to build my own executor and like just generally how to structure all of this. This is all like, I have no idea what I'm doing. Like I've written low-level like I/O reactor kind of code in other languages, but like I'm pretty new at Rust, and this is like the deep end of Rust, like writing your own async executor as far as I can tell. But I'm probably just going to have to hack at this for a bit without it really compiling. I'm also trying to do this part of it without memory allocation, which isn't really necessary. I could certainly stick an allocator in here if I want, but it's pretty compelling to me to be really strict about how I use memory in this process for simplicity and security reasons. And it seems like I can probably have some kind of internal task, which would include the like Rust future that represents the asynchronous function that's handling the system calls for a particular process. And I can just have like a one-to-one mapping between that future and a process ID and keep those in an array somewhere. So even if all of those are not like always paged in, then the virtual memory can be allocated at compile time, which makes me happy. And I mean, assuming I have like, I don't know, 1,000 tasks and 1,000 bytes per task, that's like a megabyte, which is not too bad, virtual or physical, but would usually just be virtual. This whole process is also much smaller than your typical Rust process on account of the no standard library, which is kind of nice, since we end up with a copy of it in memory for each sandbox. Hey, Tuco. Not for each process within the sandbox, but for each entire sandbox. So with one of these libraries, you could easily create a bunch of sandboxes from a single Rust parent process. And they would each have their own separate sandbox process running inside, managing the ptrace. But on the other end of that Unix domain socket, there would just be an asynchronous task running on some shared Tokyo reactor. Oh, what are we doing there? I think that's still not even worth committing or anything. I had this process abstraction in here that was not... I don't know if any of it's going to be worth keeping. So this create protocol syspid. That is really just a U32 in a tuple. Let's close some of this. Yeah, so I've started to handle the I/O problem here with asynchronous I/O via signals. This has many of its own problems, but seems like it'll work. So for the security of the sandbox, like I have to be able to lock things down with setcomp before running any of this code, really. So anything that I use to set up the socket will probably just end up being like allowed from the tracer process. Not from processes the tracer controls, but there's an incentive to just keep that set of system calls and system call parameters as small as possible. So for example, this thing where I'm setting up to send a signal via F control is a little worrying, because that means the setcomp filter either needs to allow this broadly, which seems unnecessarily dangerous, or it needs to allow this specifically, which means that I need to actually write the process ID into the setcomp filter, which is not hard, but it's just something to like make sure that we are aware of. Right now, I think F control is just enabled unconditionally, and there's a fix me note. Oh, I don't have a fix me note. That should really be... Yeah, this... Oh, some of these don't even have... Where did all my tabs come from? That's what I wanted. Yeah, it's like I haven't even written the... Oh, why are these still... Are those real tabs? That's weird. this editor just trying to be really smart, or are these actually not spaces? That is disconcerting that groups of actual spaces are treated as like rigid blocks like that. Adam, you're such a weird editor. I keep threatening to go back to Emacs, but this one looks so nice on video. Where did my F control go? Yeah, so there's a bunch of stuff that I need for now, but definitely can't just be wide open for this to be secure. Okay, that's about where I expected it to be. I don't know why Dooko's meowing. He can get in just fine. All right. So I also haven't decided if there are, like, I'm pretty light on dependencies right now on this side, and there might very well be some like no standard library, like vector flavored crates that would be useful, but I'm not using anything like that right now. These are all pretty low level. This is a library that I wrote to do the seccomp. This is our friend Serdi. This is a system call library, and this is a serializer that doesn't do variable sized values or allocation. Someone mentioned another serializer called Postcard on the last stream that seems worth a shot if this one gives us any trouble. And this one's just a macro for computing memory offsets. So yeah. Got this really low-level ptrace stuff. And this tracer object is kind of more like the main, well, tracer struct. It's really like the main thing behind this right now. The main thing that needs refactoring. This is closer to what I think actually needs to turn into the executor if this is all like in async land. So I've already started turning some of this into async, which is part of why it doesn't compile right now. So stuff like the actual system call emulation happens in here. And right now the boundary between synchronous and async is in here, which is why this was failing to compile. Handle events is kind of the main loop for this part of the program. This is designed to just loop and not return, and it's called from the actual main function elsewhere. The way this will operate right now is that this will mostly be waiting on process IDs, but due to the signal we set up, this also wakes up anytime there's a socket, anytime the socket is ready for reading. And this could be super simple where we just basically ignore the signal, and if wait ID returns that it was interrupted, we try reading the socket, that kind of thing. That's not actually super reliable though, because there's a race condition there, and it's better to at least set like an atomic flag from inside the signal. So we could do something like that pretty trivially, and then pull the actual socket from the same loop. So that's like kind of what we're doing here, minus the atomic flag. This self IPC receive is a wrapper around the socket polling. So when this wakes up, either due to an actual system call coming in, or due to like a task exiting or anything else that wait ID actually handles, or it wakes up due to the signal interrupting this whole thing, this will still get a chance to check whether any IPC messages have come in. So this is overall kind of the flow I want, but now I'm thinking about how to turn this into an async executor. So I don't really know how like wakers fit into all this, or how much of that do I need to set up? The async parts of the Rust compiler really just give you a way of building like state machines out of functions. So when you have an async function, that turns into a state machine that is encapsulated in a Rust future, which is just a type that has a poll function that you can call to repeatedly try to see if it's ready yet. So there's sort of a trivial way of doing this where you just repeatedly call poll and don't really pay attention to who's actually ready and who's waiting on I/O for what reason, but that gets terrible and inefficient quickly. So like to write a good executor, you need to keep track of which tasks are ready to run and which tasks might have just become ready to run because of an event you got from the kernel. So I'm still working on the basics here, like as far as the async stuff. This is also complicated because I'm trying to figure out how to do things statically, and I don't know if complicated is the right word, but it means it's forcing me to figure out memory early rather than making it into a runtime mistake, which is probably good, probably less complicated overall, but it means that there's more of a learning curve. So I think what I want is to have a table of virtual process IDs, and then to somehow either have that same table or a parallel such table or whatever have the actual futures, which are the structure that get generated from these asynchronous function calls. And the future type is opaque, there's no way to write it out. Futures in general are a thing that you can implement yourself, and there are a lot of different ways to make futures. But these particular futures are generally going to be created by the compiler from asynchronous functions. So those futures, I think you can use them as type parameters in things, but you can't actually write out their name or inspect them directly. But I'm still pretty fuzzy on how a lot of that works because I'm new at this. So I was making some attempt to put the future into an array here where I wasn't actually writing the type, but I was having the compiler infer it. I don't think that's actually what I want to do, though. I think I want to modify this whole thing over here. And maybe the first thing I want to do is clean this up such that a process is more cleanly represented by just an asynchronous function. like instead of having this like single ptrace loop that decides what's going on, like, I mean, this will physically exist, pointing at the wrong thing. This will physically exist in the process. There will be a loop that like calls wait ID. But like if the way that this was structured was more like each process is a separate like async task, which is individually waiting on the next event from its corresponding kernel space process. So each process could be some separate, I guess, like an async function that takes a parameter, which is something that it can invoke to retrieve the next. Like if we had channels, that could be like a receive channel, but we don't have channels yet, and I don't know if I want to implement channels just for this. I think there might be a simpler way of doing it. But it would be something like that. I think maybe even just like a single element mailbox. Because these don't need to queue up, like everything is serialized here anyway, just by nature of how ptrace works. Like the process will have these well-defined states where it's either running on its own or it's just stopped and we're about to emulate a system call for it, or we might be in various states within that. So I've already got this kind of like high-level concept of what state a process is in, which I didn't really know what I was doing when I put this in. Like right now it just has spawning and normal, which is used sort of for how fork works. But I mean, I think really the actual state of a process would be something more like, it could be something where the outer layer of it is an enum like this, and then one of the enum members is a future, which you then call like an asynchronous function. That could even be per system call, I guess. It wouldn't have to be... Right? Like I was thinking there'd be some like continuously running task and like a mailbox that you would use to pass stuff to that task. But I guess another way of doing this is that this process has a running state where there is no future associated with it. I mean, it has a future, but it doesn't have like a Rust object that needs polling. And then when it goes into the blocked for system call emulation state, the enum value for that just has that one future. Like it's not going to be a boxed future, which means like that type. I still don't really know how to operate with non-boxed futures, really. Like it's common to put futures in a box so that you can erase their specific complicated type when you're dealing with a platform that has memory allocation. But I mean, this is definitely me being a little bit stubborn and wanting to understand like in detail how this works on a platform with no alloc. But it should be possible to have the specific concrete type of that future kind of propagate out through type parameters, if I understand this right. Uh-oh, stop the presses. We have someone in need of a compiler error debugging session. I mean, if you describe it, I might take a shot at helping. But in general, those kinds of like there's a lot of context that's necessary to answer a question like that. So like part of me thinks that this like process abstraction should be sort of like the top level thing that we're using for processes, because that would make a lot of sense. And then part of me just wants to like throw it out and not even have processes like this to do this somehow differently. I also just don't want to have to write as much like faux vector allocation kind of code, but this like vector of options is maybe like a slightly specialized type to expect to just reduce to a single thing, or array of options even. All right, I also don't have a good way of scanning this. I'm just scanning it linearly right now, which is not great. That's what I want. I want to rename this file to like process table and have the process and the process table be separate. It's like this little guy needs more space. I don't know, like the actual internals of like what it means to be a process is actually living more like in the emulator. This is my vision behind this was more that like this object's lifespan is the emulation of a single system call. So you would create this with like the state of a system call that's being emulated, and it would help you on your journey to emulate that single system call. So the main entry point here is this async dispatch. And this is all stubs right now. I mean, I think that just means that a bunch of these types, like all the way back to the tracer, end up getting a type parameter for the specific future type of that dispatcher. Yeah, and then this is created on the stack. I have no idea what I'm doing, but I think we can try this. Maybe I can find the section of the Rust book to review. So every specific future type adds a lot of overhead here, so there probably should just be one, and it seems reasonable that this dispatcher could be it, but maybe we want something slightly higher level. This is where it seems appealing to instead just have like a single kind of abstract task future that doesn't take parameters but just runs continuously. Like most of what we're dealing with is like system calls, but I mean there are some other things that ptrace throws at us, like like fork is usually special cased, and like process is ending. And it seems like we'd want to keep those separate and asynchronous. Yeah, so maybe emulator will be more like a utility that the process uses to do system call emulation. And then I do kind of make room for process to grow into something more substantial and move process table into its own spot. And all of this mess can live in process table until I rewrite it. It's tempting to make a directory at this point. So having second thoughts about this file name is like way longer than everything else in the project at this point. Like IPC and ptrace are both kind of similar in that they're sort of event providers for the rest of the program. But then like seccomp and emulator are both about system calls. Pretty differently though. I think I rename emulator to process/syscall. PIDs are really part of the process table, not the process itself. I'm thinking about whether the entire state of this thing should be just encapsulated into a future and not have anything to do with this enum. I think that's it. Yes, I'm catching up on chat a little bit. The first question was if you had a compiler error, where would you look? Is what I'm asking. I mean, canonically, the manual for the compiler. That's probably not where you're going to check, though. My actual answer for that is it depends on whether you think the compiler error is something that you should interpret literally or that you should use it as a clue for your investigation. So if you think that literally the problem is that you did something wrong and the compiler is telling you what you specifically did wrong, then look up what the error means. If you don't know what the error means, look it up, but be prepared for it not to be a specific direction, but to just be like a pointer toward the problem. And then look for context clues like, does this problem seem to be caused by my code? Does this seem to be caused by the environment I'm compiling in? Does it seem to be in a particular module? Like, what overall category of error is it? Can I make some kind of change to the environment that causes the error to appear or disappear? Like, are there other projects that have similar errors? And you can certainly search the web for your error, but you also want to keep in mind some of those context questions when you're looking at other people's descriptions of the error, because again, your problem might not be that specifically related to the text that you're getting, or maybe it is, depending on what's really going on. I guess this means that all the processes that have not yet started will just be if I have room for 1024 processes or whatever, there will be no uninitialized process state. They will all be futures that are runnable. Which seems fine, maybe. I don't think that's a problem from a memory use perspective, but it might be an initialization time problem if there's actually something that it concretely needs to do to all those separate slots in the array that's non-trivial. Should be trivial though. I don't know why it would be doing something other than just setting it to a constant value. Trying to think ahead to what kinds of events we're actually going to need these to handle. There's a simple version of this where it's basically just one future you pull. I think it might also need some kind of communication channel set though. How do we actually get the results of an RPC call back to here? And what kinds of communication channels might we need for other purposes? If we want to, I don't know, if we want to implement some kernel functionality in emulation that requires messaging between tasks. It would be, if we had a channel, that would be another case where we could just throw a channel in here. So if we have more than a couple of things that are really point to channels being a good solution. Maybe we just try to implement channels on top of this. I don't think I can derive debug if I'm doing that. I guess we still do have that option process, so we're not initializing anything ahead of time. Right, because we don't always have a system PID. That's fine. But like, who even uses... Like, who even needs to know what the system PID is? Like, that seems like something that ptrace needs to know. Welcome to the staring at an editor while muttering about architectural decisions stream. That's a weird place to allocate the process. From Twitch chat, this compiler error continues. So it looks like the problem is that the code is supposed to compile and doesn't. I mean, you could complain to the person who wrote it, or you could debug it. Like, that's the bit too basic options. Often it's faster to try to debug it yourself than to wait for the person who wrote it to respond, but it depends on your situation. But like, I mean, if you don't know what's in it, like, I mean, you've got the source code. You could look at it. You could, I mean, so like, there are various starting points available depending on what you're doing. But I mean, I was being a little bit silly when I said to read the manual for the compiler. But I mean, if you have specific tools that you're using, those tools probably do have documentation that tell you how the language works and tells you like what the errors mean. So while that might not be in the end what you actually need, that's at least a starting point that points to other things that you can look at. Yeah, so this expect new child is sort of weird. We're using this both for the very first fork that we do to be the child process, and we do it for furthermore for emulated forks. So like one way I could imagine this working that would be architecturally kind of nice is that, so most of this stuff goes away. That process becomes just an asynchronous function that you call with the system PID, and then it uses some asynchronous version of ptrace to wait on events specifically for that PID, which internally would then convert into a more generic wait ID plus like a dispatch system. Like it seems like it would be useful to use the system PID as part of the dispatch here, but like we don't actually have an efficient way of storing that yet. Like this process table is really phoning it in, so it's like if we have a better way of doing it, that would be nice. Are there any good no-alloc hash tables out there that we could use? And we can go cargo shopping. Oh, it's just lib.rs. Yeah, I've seen this one before. How low level is this? Does need an allocator. It'd be great if there was some way I didn't even have to make this lookup like I could store the data some other way. But I mean, I do think I need some way to get that like mapping from an operating system process to an emulated process. And it seems like a small fixed size hash table would be great for that. I don't know why that would require allocation. Array hash table? Ah. Huh. I mean, this uses an array of x. I mean, you could just write a little hash table thing. I don't know if there's like a real name for this, but we could use the technique where, you pick a bucket using some arbitrary hash function and you move to the next bucket if the current bucket is full. And so if you, in the worst case, are searching for a key that isn't there, you might have to scan the whole table. But in more common cases where the key is actually nearby, it's pretty fast. So I mean, that would be no allocation, and like the worst case would be no worse than what we've currently got. I'm still imagining that limit of like 1,000 processes is fairly realistic, if not kind of high, because I would figure you're mostly just running like media transcodes and stuff on here, so you maybe have a couple times the number of CPU cores, and that's probably it. Ooh, hash ring, is that what we're talking about? The really pedantic part of me that wants to do everything at compile time would be super satisfied if we could avoid memory allocation, but it certainly wouldn't be the end of the world to do some memory allocation. We could likely get away with a very simple allocator and just have everything allocate like once at initialization time. But it would be cool to do it at compile time instead, and the compiler would be extra pedantic at enforcing all of this. Does this work without alloc? Wow. How does this work? This must have a requirement in the global allocator that they just haven't mentioned yet in the docs. Is that Tuco? Hey, Tuco, what are you doing? Hey, you just want to say hi with your head. Hey there. Oh. Yeah. Oh, did the camera overheat or did I turn it off? Hey, Tuco. Come on. I think he just wants me to hang out somewhere else. Yeah, that's using the B-tree map from the alloc crate, so that's for certainly using the global allocator. I think there are a couple of crates kind of like this, the static vec. I kind of need something like this, but I'm still just a little grossed out by how you need a type representing the number. And I might just wait on that. Oh wait, is that actually... Oh, that magnet might actually be better than what I thought this was. There's a different crate I was thinking of where they used this like big pile of constant types that were just numbers. But this seems to be using an actual number. Like that looks perfectly reasonable, which is great. Maybe I will use this. Oh, that's great. Ah, I should definitely use this. This is much nicer. Okay, the older style I was seeing, I think that was in one of the dependencies for that other serializer I was looking at. Heapless. It's an optional dependency, so I can certainly go without these, but yeah, this is what I was thinking of. I don't want to pick on this library too much because I've seen plenty of people do this because I don't think the other style was available until recently. But yeah, that seems better. So let's maybe use that. I would also like a map of some sort. What is this? Was this from before the compiler had generator support, or? Oh, that's weird. I'll have to figure out what that is. Does this have anything else in it? Oh, Heapless does have an entire... Yeah. Gosh, maybe I should just eat the terrible syntax, because this does look useful. Gosh. Really? This could be super useful. Wow. Do we have single? Yeah. Gosh, yeah. Maybe I do want to use some of these as like mailboxes. Alright. I'm probably going to start filling my code with heapless objects at this point. Because, I mean, that does seem like a compelling little ecosystem of Rust thingies. I might also want to grab somebody's no standard C string crate, since I saw some of those around, and I've got some code that would benefit from that. Hmm. This whole thing can certainly go into the ptrace specific thing. It seems slightly useful for performance reasons to only initialize this once, but I don't think it actually matters. It's probably safer not to give the kernel any uninitialized memory anyway. I've been treating most of these like really low-level ptrace errors as just panics, but this might be something to do separately. In this context, ABI eChild means that there are no more child processes, which actually means that we're exiting the container. So I think we can just make that an option. Hey, Tuco. He's standing right out of frame. Hey. Hey, Tuco. Does not want to be picked up. Right, and it seems like I can just make this same, like this type has more stuff than I really need to put in that queue, but I could just use that as a data type for the queue because I already have one that I own. Oh, that's right. SIGinfo doesn't actually have much information in it. I'm getting most of my info from the CPU registers. Just feels like an annoying amount of memory to zero every time we have a system call, but I'm not going to worry about that. Fine. Yeah, I don't think I need one of those owned. It's a lot less elegant, but I mean, I actually like the way I like the way this treats the memory better. So that would be more like what it was doing. And then you'd probably have something immediately just read the process ID out of that and then not use much else of it. I wonder if there are any like asynchronous channel implementations we could just use in this context. Syntax highlighting keeps arbitrarily breaking in this version of Atom. I mean, in this case, I'm sure my syntax is actually bad, but I think yesterday we were having some weird arbitrary breakage. Something more like that. Hmm. What are the units? Oh, clock cycles, wow. Gosh, this must be fun to use on embedded. Alright, maybe PID limit doesn't get defined like that. Oh, 2 goes back. Oh, these heapless consts are such a trip. It's like the worst thing I've seen in Rust so far. Just moving stuff around so that the process table is going to be more like a bimap. But I think I'm just going to use 2 of these heapless index maps, and that'll keep track of the relationship both directions between virtual and system process IDs. And then the actual process, I think that's going to be a future which implements the sort of asynchronous task for that process, plus a handful of those queues. I don't know yet whether I need like a multi-producer or a single producer queue. This is generally single-threaded code. At some point, I'll be wanting to generate events from signals, but those events can be quite simple. Very good cat. Aw. See if we can get closer in on the cat. You getting up? You looking me directly in the eye. Oh no, he's licking me. Aw. Baby. Hmm. Ah, she likes these head rubs. Now he's getting up. Alright, back to work. He left this big pile of cat hair. So I changed this PID limit to one of its type constants, and now I'm thinking the process table looks more like this. Oh, so process is probably going to be parameterized. I figured that was going to be the task type. Oops. Ah, this should be an option process. Okay, this is a much more compelling data type for the process table to be. don't know if I care whether vpit is a reference or not, because it's just a single word. I think it makes more sense for vpit to be a reference. I think I want that vbit to be owned. It definitely could be a reference, but I'm going to have one anyway. Oh yeah, there's cat hair everywhere. I mean, it's not too hard because I don't have carpets here, and I have a pretty powerful vacuum. But yeah, Tuco certainly has a lot of hair. Hey, Tuco. Hey, Squeaky. Hmm. I don't know what he wants right now. I think this just panics if the PID is already used. There isn't already a heapless bimap, is there? Yeah, the thing I want is conceptually that, but without allocation. Do I want to be in that position of reusing PIDs eagerly in the sandbox? I don't know about that. I think I want the same behavior as Linux, where I only take slots after wrapping around one entire time. Right? So I don't think I even have a recycled vpid list. That also implies that the state of this is different from the... Like this hardly needs to be a vec, right? This is one of those heapless vecs, but it could also just really be an array that's initialized all to none. Doesn't really matter. It's kind of nice, though, that I can explicitly say which PID is first or next. I did actually have code in place here before to make table indices and vpids different so that I could skip 0. That is pretty funny that these are actually... Like, if I understand what they're doing, it looks like these are like binary numbers. Like, what are P and N here? Positive and negative? Oh, yeah. Cool. I came here looking for a way to resolve this to like an actual integer in case I want to make an array. Gosh. Where's that uint? Don't these come from a different crate? Hey, Tuco. Hey, Tuco. Hey, Tuco. Generic array type num. Oh, hey, Tuco, you're back. Okay, and then generic array gets this all from another crate called type num, which I'm sure I've seen. I was just looking for a direct reference. And here it is. Whoa, there's one of those tiny red spiders. There's a lot of spiders on this side of the house. It's next to the plants. Gosh, type num is so weird. Okay, they have an unsigned trait. Oh, cool. There are there are both constant versions of the numbers defined as consts in the type, and there are functions that you can call on the instance of the integer type. Deciding how I feel about process ID 0. I think it might just be an empty spot in the table. The alternative is to have table indices and process IDs not be the same, which is what I was doing before. But then I also need the table size to be different, which I guess I can do without making this heapless const be different. I can do the -1 after I convert it to a real U size. Maybe let's get to go on a smaller screen for a minute. treating vpit as void. I feel bad about even constructing that vpit before I know it's valid, because I feel like the constructor should be checking that. I mean, it doesn't have a constructor, it's just a tuple, but conceptually. I think Rust is super fun. Yeah, if anybody out there is interested and has time to learn Rust, I think it's totally worth doing. Yeah, Tuco agrees. I feel like I could do this whole thing with a match. I don't think I can do that. Maybe something like that. I don't know if that's actually right. Alright, I do actually want to propagate errors when the table is full. I don't want to do that. I thought I needed the mutable borrow to end on a separate statement than what I'm about to do next. hey, Took. Hey, Tuco. It really wants to be a dot map, right? But I wasn't sure if that would work with the mutable self borrow there. Let's try it. I don't think this is going to work, though. Hey, Tuco. Why are they using unwrap in that example? Oh, that is a result. I thought it was just an option. That's defined as copy. Isn't syspid also defined as copy? Yeah. Okay, so I can convert both directions, I can allocate, I can insert. Now I just need lookups and free. Oh, we might want to be able to get vpids that are invalid without that panicking. Oh, this is similar to what I already had, isn't it? Pid to index. Hmm. Okay. Hmm. If like all my incoming I/O events can be delivered directly to one of these process or tasks, that would be great. Then I wouldn't need another data structure to keep track of that. The process ID events, so I've already got a way of getting to this task from a system process ID now, which is how I get my ptrace events. And then I've got RPC events, which are really just up to me. Like there's one shared RPC socket, but I kind of haven't added a way to associate RPC replies with RPC messages yet. I figured that was still coming. So that could be done based on virtual process IDs, maybe. In that case, maybe if I do have a multi-producer queue for the incoming RPC responses, I can do that I/O directly on the signal handler. Either way, though. So like I might get some benefit from a multi-producer lock-free queue, but this also might just be super overkill because I could do all the I/O outside the signal handler and have a single producer, single consumer queue. This is nice. It's a lot of code. I'm glad I don't have to debug myself, hopefully. That's handy. They do go. Oh, you're so heavy. You've been eating. No? Okay. Yeah, it's pretty normal. Go. I was thinking about queuing this type, but I feel like this type needs a wrapper that indicates what task it's destined for, and then whatever else is in there gets enqueued. I don't know what Tuco wants. Oh, Tuco. Well, in that case, VPIDs, we've found the point at which they become part of the protocol. Hey, Tuke. Shh. Oh. I liked keeping the messages in each direction as separate types. I'm not sure how useful that really is. But I mean, a typical message probably will have substantially separate inputs and outputs. Something like mmap, for example, would to go. Like the inputs would be, I don't know, mmap is also weird because the output for that is probably actually a file descriptor. I don't know if there's like a normal naming convention for... There's this pattern I've found in Rust a few times now where it seems like you need like an outer structure and then like an inner enum for something that are conceptually both really similar. Like in this case, I have this thing which is an entire message that I'm sending to the sand process, which wants to be a struct. But then I have an enum, which is the type of message. But the direction is still important, I think. Oh, there's a question about what editor this is. This is Atom. V2 go. V2 go. What are you destroying now? He found my stash of extra coax, but it's all cat-proofed. He's gonna test my cat-proofing though. Like this message layer might also end up having to deal with some of the file descriptor passing stuff. I'm also not sure if I should continue trying to name these in sort of a symmetric way, like about the direction rather than about the phase of the operation, like a command or reply versus like to sand from sand versus like to IPC server from IPC server. I feel like server client are like the least useful. I mean, I'm sure there are worse, but like it doesn't really tell you much, and it's often confusing because the server and the client are pretty arbitrary, and you have to kind of know how the protocol works before you can use that to describe the protocol. So like this would be from the IPC server to the emulator. This would be from the emulator to the IPC server. This is usually a command, and that's usually a response. I don't know if I want to commit to them always being command response pairs, but it does seem like they're always going to be about a specific task. Like even stuff that seems like weird, like how does it load the very first binary? I mean, that's just the loader task. Like I think anything that does have to happen, because like the sand binary that I have that is like the first thing that goes in the sandbox, it actually forks so that it's sort of running one version of itself that's called the tracer and actually runs the ptrace system call trap and emulate thing. And then after it forks, there's another version of the same binary running as a loader, which I think that's what actually issues either a normal or abnormal exec to get the first like real sandbox process going. Either the loader runs a normal exec, or the loader does something slightly weird to get the system, or to get the entry point binary specifically, but I think it might just be a normal exec. I think maybe it does something weird to get the parameters for that first exec, but then the exec itself is normal. Try writing something a little more real here than just no ops. I think that'll illuminate this a lot. I keep wanting to call these commands and replies, and maybe that is the right answer. There's also the pattern of embedding a copy of the command in the reply, which often doesn't have any point, but can be convenient. I keep wanting to start with an mmap, but mmap is actually kind of a complicated example. I mean, a simple example would be like open or stat. Those are definitely commands and replies. Okay, what happens that is not a command and reply? Like, do we have like actually asynchronous stuff? Also, how do wake-ups work? I mean, most things that, like most strategies for I/O in the sandbox, like, I mean, I'm building this mostly to run FFmpeg, so like for the most part, it's going to be reading from what it thinks is a file, and the sandbox itself actually implements as probably like a Tokyo stream or something within the host application. So for cases like that, like even if it's using like select or epoll or whatever, like all we're doing is emulating system calls that may or may not block. So then there's like signals. Do we care about signals being expressed at this level? Like what if they were trying to do async IO using sig.io from inside the sandbox? What would that look like? That's not something I care extremely much about supporting because it's so uncommon, but it's an interesting thought experiment. like the process we're talking to over the RPC, at the IPC thing, that's the one that has permission to issue like real signals anyway. So if we need a signal delivered, like we would normally be asking that process to do the signal delivery, to like wake up another task for us. So is there anything that doesn't fit into the command reply kind of pattern? I mean, it doesn't seem like something that I need to support right now, but it's like, I'd really rather not rule it out, you know? So if there's a way to make this semantically easy to think of as commands and responses while still allowing asynchronous responses, that would be cool. Like, how do new tasks come into being? I think we always know to expect them ahead of time and allocate their process ID. Right? There's still a couple of different ways the path names could work. Like, I could even imagine having the tracer be responsible for gathering those parameters. I was kind of liking that limitation, though, where our protocol doesn't have any variable size data in it. Like, it seems to make sense to have the other process like get its own mapping to this address space. Like the sand process is really locked down. It can't open anything directly. It has to ask this other higher privileged process to do all of its file system operations, but that includes stuff that's in /proc, which like proc self and the proc pid mem for the processes we're tracing. I'm thinking there's going to need to be some component where that higher privilege IPC server can verify that we have the ability to mmap another process's address space, which I feel like there's definitely a way to do that which is almost race condition free, but I don't know if there's a way to do that that is 100% race condition free, which is a problem. And then, another interesting question is there an advantage to having the runtime process not allowed to map the memory that the sandboxed code might also have access to? Like, is that an interesting security boundary to have? I'm not really sure that it is, and it seems useful for I/O purposes to allow memory mapped I/O. Like, that would be pretty great. This format should actually even be slightly weirder because the file descriptors that we're going to be passing around are separate from the serialized portion of the message. Maybe it would be nice to just collapse these into a single message type. I guess the other way to think of the file descriptors is just as a separate parallel queue to the messages. So you don't actually represent it as part of the message, but it's like assumed that when you process, for example, like an open reply, like when you generate an open reply, you're also in queuing not only that, but you're in queuing the file descriptor in a parallel queue. It's like pretty close to how the underlying socket works, but is also not the most ergonomic. I don't know how often the sand process is going to need to actually touch the memory mappings. It does seem like both the runtime and the sand process, at least the way I'm headed, would each need to deal with the memory mappings for maybe different reasons. Like the IPC server would need to memory map the parameters for like an open call, for example. And for a lot of like file system calls, the one place we read that parameter is in the IPC server. But then there's stuff like the L floater where I probably want to map the whole L file into the tracer process and then do the header parsing there. Yeah, like even something like open probably wants, like the reply probably wants to indicate very specifically whether or not it includes a file descriptor. I could probably have some kind of type that'd be like a token indicating that there's also a file descriptor included in this message. Like that type itself, like it could look like a bool or something when you serialize it. I don't know if there's a good way for serializers to have like weird bits of external state like that. I don't know if that quite does what I want, but somewhere to start. The other thing is maybe I don't know, maybe there are fairly few, potentially even just a single message that's about receiving or sending file descriptors. I don't know. Oh, Tuco, don't break that. descriptor wants me to adjust the window. Oh, Tuco. Hey. 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 I haven't even really thought about the whole path of how we get file descriptors back to the other process. Right? Because, like, I'm sending the file descriptor through a Unix domain socket to this tracer process, but the tracer process isn't the actual process that's requesting the file descriptor. If the tracer was emulating read and write, then that would be enough. But I think we want to try to not emulate read and write and actually have this be a file descriptor in the sandbox process. So I think that means that we end up having to use another Unix domain socket to pass files between the tracer and the processes that are being traced. So that means everybody needs receive message and send message probably, which is probably fine. I keep thinking about the data types that go in here. It's like, okay, I need some queues of like a system call, bits going in and out, but like, it's not just that. I mean, so going in, we have not even system call related stuff, but just like the actual signal notifications from wait ID, which are used to start system call emulation. Like after we get one of those signal notifications from wait ID, there's still another system call to get the registers, and then you emulate the system call and then make another real system call to put the registers back. So all that can just be within the context of one async function. How much does this not compile right now? Like, let's say we're emulating open. And we just woke up getting a message back from the IPC server with the file descriptor that we want to send as the result from open. So one problem is that that file descriptor is in the tracers process right now. Like, it is a kernel object that the tracer has a handle to effectively, but that file descriptor doesn't work in the other process's file descriptor table. So somewhere we need information about Are we gonna have to have... this makes the I/O strategy actually a lot more complicated if the tracer needs to be sending and receiving to file descriptors for each of the traced processes. I'm not sure that's really necessary though. Like a traced process is never going to surprise the tracer by writing to a file descriptor, is it? I mean, so we don't care about the like application level file descriptors here. We're talking about the inter-process communication file descriptors. And I think that's only needed for sending, like conferring access rights to file descriptors. I don't think we ever need that as just like a signaling mechanism. I don't know if I picked the best stream content, because here I am just thinking about architecture and staring at a blank editor for the most part. Yeah, this is maybe an interesting difference between how something like exec and something like open would be emulated. So for open, we're getting a file descriptor here in the tracer from the IPC server, and we don't actually want to do anything with that other than just send it to the actual process being traced. Now the actual process being traced, like it's not our code. Like we don't have really any foothold in its address space unless we take some extra steps. We do have the ability to easily change its CPU state while it's stopped for a system call, and we can less easily do stuff like access its memory. We could write additional code in. We're going to be doing the elf loading ourselves, so if we need to like translate in additional like stuff and leave it in their address space, we could do that. But I'm just thinking, like, how does it look like when we're returning from a system call, and from the tracey's point of view, it looks like it thinks it just called open, like a regular open syscall, but we're actually returning from an emulated open that needs to somehow get a file descriptor into the AX register. So like what happens then? I think we want to emulate a receive message. And I think that probably involves some situation where we're not actually, like both the sender and the receiver on that Unix domain socket are probably expecting exactly what's happening. So like the sender puts one file descriptor into the queue and expects that there's no blocking and that succeeds. And then that sender, which is also the tracer process, resumes the tracee, which then right at that moment can do a receive message and just get the one message that exists in the queue. So I don't think we need any new flow control, but there's this weird inconvenient thing where the guest thinks it's, I keep calling it the guest because I'm used to like virtualization, the like process inside the sandbox thinks it's returning from a normal open syscall, but actually we need to rewrite the open syscall into a receive message syscall somehow. Like, does that look like we're writing the system call and then returning control, or does it look like we're executing a system call within a system call? Hey, Tuco. Like, I mean, it seems like one way to do this would be for open, instead of returning normally, to set up something that looks sort of like a signal handler, I guess. Just like push another stack frame on, and within that little handler thing, it could receive the file descriptor from a socket and format it correctly and return. But like, where would that code live? It would need to be in the address space somewhere. It could be in the VDSO. I haven't written that yet, but like, we're probably going to have some code that actually is written specifically to be in that address space, and it'll be the kernel VDSO, the virtual dynamic shared object. So maybe that is how this works. Maybe open, maybe what open looks like is a emulated system call that then trampolines into a socket receive thing that lives in the VDSO. That would be weird, right? Might actually work. So if we were doing that, this data structure, this process, what I'm thinking right now it's useful for is getting asynchronous events into the async function in Rust that implements syscall emulation for one process inside the sandbox. So task would be the actual future that we're pulling. So it's an opaque type that the compiler generates. And it actually represents the state machine that the async code is transformed into. But then I think there could be a queue of why a queue, right? Because like this is a state transition. There are never going to be multiple system calls pending, right? So like it could be more like, I'm thinking conceptually it is a queue of size 1. Is that a thing that makes sense with this library? Right, I mean, it could probably just be something like an option and an atomic flag. But like, other than our signal handler, this is all single-threaded code. Do I ever need to receive file descriptors from the emulated processes? I don't think so. Like, the emulated processes can't open anything, so like all of their file descriptors are coming from the runtime anyway. So the runtime can just keep a copy of something that it wants. I think the traced processes can't even create their own socket pairs, but the tracer needs to be able to create socket pairs. Well, I feel like the interesting parts of this stream, such as they were, have probably wound down. I'm gonna maybe make some food and think about this some more, but I'll try to stream regularly and give folks updates on what I'm doing and not worry quite so much about each one being a marathon, but just try to do them more regularly. So yeah, mostly just trying to make some sense out of this weird little sandbox project while kind of also thinking about video stuff too. Thinking about how to make all of this infrastructure. Oh hey, it's Tuco. Tuco, do you want to say bye to folks? Whoa. No. I think Tuco wants to visit, but he doesn't want to be picked up. That's cool. Well, thanks so much for stopping by. And special thanks to everyone who supports the channel on Patreon. Helps me pay the electric bill and pay for the health insurance and keep this going. And if there's anything in particular that you want to see or, comments you have, feel free to drop me a line. I try to keep up with the comments on the various socials. There's always Tuco's Twitter account if you just want cat pictures. All right. Have a good night, folks. Happy hacking. See you next time. Oh, and speaking of next time, if you want to get notified when this is happening, there's a Scanlime Live account on Twitter. You can also just do the notification thing on YouTube or follow on Twitch, that kind of thing. See you next time.